Welcome. This is Nathaniel P. Wilkerson with Medeek Engineering, and today I'm going to talk about using the basic features of the Medeek Truss Plugin. So basically, we're talking about the plugin that I recently created starting in October 8th. It's called the Medeek Truss Plugin, and here's just a quick screenshot of the Truss Plugin webpage that just details some of the basic features of the plugin. So today I'm going to open up SketchUp 2015. I could use 2016, but 2015 is where I have all most of my work. And as you can see, I've created a toolbar for the plugin called Medeek Truss Plugin or Medeek Truss. There currently is 5 icons in this plugin for the different features, and I'm just going to put that back. So to start with, let's just take a look at creating a basic truss. And if you look at the icons up here, you're going to see this triangular truss icon. That's for all your basic truss types, your roof trusses. And then you're going to see the square truss icon, and that will be for floor trusses and floor joists like TGI joists. And in the future, I think we'll also add in some solid sawn joists as well. This one here is for drawing truss sets. Now, there's only one truss set option available currently, and that is for valley truss sets. But in the future, we'll be adding hip sets and other, more exotic truss sets. And then at this icon, we have roof rafters. So you can draw different rafters. Roofs like gable roofs and TGI roofs with glulam beams and hip roofs, and then later on we're actually in the process of adding gable roofs with a solid sawn beam as well as shed roofs. So let's cancel that, and then we've just recently added the engineering icon, and what this allows you to do currently is select a truss or a beam and actually automatically export the parameters for that truss or beam, and it takes you into the truss calculator or beam calculator on my website, and we'll do the engineering for you. Of course, you still need to know some information like loads and that sort of thing, but we'll get to that in another tutorial. So to start with, let's go ahead and click the the truss icon, and as you can see, there's a drop-down box here for different families of trusses. Now, common truss types, of course, are what you normally see on a regular triangular shaped roof. So you're going to have all of your fink and your how and all those. So we're going to start there. And actually, to be honest, right now there's only 4 of these truss families that are currently active. These other 5 are currently in development. So the gambrel attic is coming soon, as well as a dual pitch. And then we're going to be looking at adding these other 3 as well. Let's start with a common truss type. So as soon as you hit OK, it's going to prompt you now for 3 points. So you'll notice down here in the lower left corner, it says click front left corner. Okay, so you click the front left corner of your building. Now, by the way, you can go ahead and have a building and go ahead and click the 3 bounding points on that building. But for now, we're just going to click here anywhere, and we'll just click at the origin and then stretch out here. And notice how you can also, it prompts for the out-to-out span. So you can actually key in right down here what you want that span to be. So I'm going to actually key in 26 feet. And then you just hit enter. And then you'll notice now it's showing the bounding rectangle. So now you can stretch out here, you can click, and it'll go ahead and set the building length as well. But I'm going to go ahead and key in 32 feet for the length of the building. Okay, so now it prompts you here on the second prompt, and now you can actually select the different truss type. And you can see there's a few of them here. And really what these are, it configures the internal webs of the truss. So you start with the typical smallest truss type all the way up to a double fink. And in the future, I'm also going to add a few other more like triple finks and quadruple finks and double hows and that sort of thing. But for now, let's just use the most common truss that's used, and that's the fink. And notice how it's got the span, which you can actually change again here if you like, or refine it to whatever you want, but it automatically puts that information there. This is the top chord pitch, and the pitch, as you probably know, is simply the slope of the roof on a 5/12 basis. Now, so with the overhangs now, you can actually adjust the overhangs independently of each other, the right and the left overhang of the roof. So in this case, it's 12 inches, but for those people like myself that are lazy and don't want to have to adjust both, you just leave this same as left and do it. It'll keep the right overhang the same as the left overhang. Okay, TC, BC, and web size. So TC stands for top chord. That's the top chord or the top member of the truss. And then the BC, of course, stands for the bottom chord. So typically, with a basic truss this size, a 2x4 is your regular size member that you're going to see here. So 3.5 is, and that's why it defaults to 3.5. Usually it's going to stay at 3.5, but you can alter these and modify these to any size of lumber that you choose. And you'll notice I have some preset lumber sizes in here. With the metric version of the software, this actually opens up and you can use any size you like. And in the future, I think what we're going to end up doing is making some global options or global settings that you can modify, so that you can have preset. You can determine these preset settings, or you can make it so that it doesn't give you preset settings and you have to key in what those sizes are. But let's just go with the 3.5 inches for now. Ply thickness, this is the thickness of the truss itself. So, typically it's a 2x4, 2x6, 2x8, that sort of thing. So 1.5 inches is your typical 2x member. And raised heel. So this is for raised or energy heel trusses. And actually right now the Fink truss is the only truss type that currently has the raised energy heel. Well, actually that's not entirely true. The mono pitch truss and the Fink truss both offer a raised heel option. All the other truss types right now do not currently have that option, but let's just leave that off for now. So let's just hit OK. And then it takes you to the third dialog. So this gives you the building length, which we've already put in with our points. The truss spacing, so this is the on-center spacing between trusses. 24 inches on center is pretty typical. And you can see again that we've got a whole array of typical truss spacings that you can use. Okay, Gable End Trust. So this option gives you, it creates the truss at the gable ends and does the vertical members oriented, at either 24 on center or 16 or 12 or whatever you want to use. 16 is kind of typical, 24 is as well. So, but we're going to do that so you can actually see what that gable end truss looks like. And then now if you go ahead and create this without the advanced options, it'll create the basic trusses and the gable end trusses, but it won't actually create all the other interesting stuff like the fascia boards and the rake boards and the sheeting. But let's go ahead and do that just so we can show that as well. So let's just go ahead and hit yes on that. And so now it'll actually prompt us one more time and takes us into the advanced options. And instead of turning the sheeting on, we're going to just leave that off so you can see the trusses. It's more easy to visualize things that way. We're going to turn on the subfascia, and the subfascia is the board, for those that don't know, at the fascia or the end at the overhang of the truss. So if we want to, and by the way, every one of these is optional, so you can turn them on off independent of each other, and you can show different things. And so we'll leave that on. The subfascia type here is a drop fascia. There's 3 different options here, and in the manual that I'm creating, I'll have a little detail that shows the different configuration of each of those, but drop fascia is pretty typical. And you once again go ahead and set the width and the depth of that fascia board. The rake board is the board at the gable ends. It's like the fascia, but it's just at the gable ends. And then you can actually set the gable overhang. So here we have it set automatically at 16. Let's go ahead and let's leave it at 16, I guess. The rake board, once again, just like the fascia, you can set the width and the depth, so there's lots of options here to choose from. And then we get to the outlookers. So the outlookers, you can turn those on or off, and of course you can set the spacing, the on-center spacing between them. And 2x4 is pretty typical around here, so I'm going to use this 2x4. Now this option is really interesting, the structural option. So For overhangs that are 12 inches or less, typically you don't need to use a structural outlooker. But in this case, we're running with a 16-inch overhang, so code requires that we use a structural outlooker. So I'm going to turn that on, and you'll see what that does. And it's going to actually affect the gable end truss by dropping the top chord. And then the orientation of this is the orientation of the outlooker. So we can either orient it horizontally or vertically. And we'll just leave it horizontal for now. And then this will actually draw the outlookers at the peak. So we'll just go ahead and leave that for yes as well. And then the heel blocking, actually this option currently doesn't create any heel blocking. The heel blocking is still under development, so we're just going to leave that off. And by the way, if you do select yes, it will just ignore it and doesn't do anything. So hit OK. And there you have it. There's your roof. So let's take a quick look at what we've got. So first things you'll notice is if you click on this, you'll notice it's all one large group. And let's click the entity info. And you'll see I'm leaving everything on layer 0 because I don't know what people want as far as layering goes, where they want to put things, but if you want to move things to different layers, you can obviously do that. So I'm creating everything within one single group, so you can easily move the whole assembly however you want to move it or twist it or rotate it. And then I name it a special name, and I use the timestamp so that if you create another truss assembly, you can keep track, and keep them separate as far as what the names are. It's just an easy naming convention. Okay, so now, first of all, you can see that we've got the gable end truss with the gable webs or struts running at 16 inches on center, and these are all. And you'll notice too also that this is a fink truss. So if we click in here, and then we're just gonna take a copy of this component here. Let's see, where's the shift key? Whatever, we'll just pull one out here so you can see what this truss looks like. Okay. So the first thing you'll notice is I've created a component out of this truss. So all of these trusses are the same component. So basically, if you were now to edit this one component and trim this or put some hole in or something, it would replicate that across all of these trusses because they're all the same component definition. And that may be useful for somebody that's trimming the tail of the truss to make it some particular geometry or something. And you'll also notice that this gable end truss is also a component. So this gable end and that gable end are using the same component definition. And then all the other trusses here are using the same definition for their component as well. So it just makes it easier for editing down the road. Now, another thing you're going to notice as well with these components is if you go here and you go component options, you're going to notice that in the dynamic attributes, it's storing a bunch of information related to this particular truss and its geometry, and also additional information that is engineering related. So, and you notice you can actually change some of these options, and down the road we'll probably have it so you can change more of these different parameters as well on the fly or after the fact, so that you can modify the geometry once you've created it. But right now the geometry is pretty static once you create it, so to change it you're going to have to basically recreate the truss. But that's pretty easy, as you've seen. So but all of these parameters can be they're used in the engineering portion of the truss when you click on this engineering icon up here. So, but let's return back here to the truss and just look at some of the features here. So if you click into this here component, you'll see that we've got basically different solids or groups that form the members and the chords. So this is the top chord here. Here's the bottom chord. Here's the left top chord. And you can see TCL, top chord left, top chord right, and then it goes ahead and it members out. Basically, we're identifying each one of these members, and they're all solids. So that's kind of the methodology that I'm using in creating the geometry and how I'm organizing things. And similarly, we've got this Gable End Trust here, and if you click into that, you can see that you've got top chords, and you've got these webs, and they're all groups, and they're all solids, and it numbers them one. Starts at 1. Actually, it's the king post right at the center, and then it numbers them this way, and it numbers them that way. But let's get back here to the geometry of this particular Fink truss and what's going on with these outlookers, because that's really quite interesting. So when we created this truss set, we basically used structural outlookers that were horizontally oriented. Now you can see what's happening here, and it's rather interesting. I'm going to click out of that group. In fact, I'm going to undo that move. So we'll just put that back. There we go. Okay. So, so here's our roof, and if we had clicked sheathing, we would have it would have the sheathing showed as well. In fact, I'll show you that right now, real quick. Let's just create another one real quick. We're not going to change any of the parameters. So we go Fink, show Gable End, yes, yes. I'm going to turn the sheathing on this time, just to show you what that looks like. Just leave everything as it is. Yeah, sure, turn the structural outlookers on, that can't hurt. Okay. And there you go, there you have it. I think that was a 7/16. And notice how the drop fascia board or subfascia is dropped, and the sheeting extends out right to the end of it. Okay, and so how that is configured is dependent on which option you choose for that fascia board. But we'll get into that a little later. So you can see that yeah, you've got a full roof here basically, all ready to go. It's got the sheeting, it's got all the fascia and the rake boards, the outlookers, and the gable ends. Okay, so let's take a look at the geometry now. So with the structural outlookers, what that option does for you essentially is it drops the top chord down to allow the outlookers to pass over the top and to contact and anchor back with the next truss, the next common truss. And then right here you'll notice that this one terminates short because we don't want it to notch the truss right here near the heel of the truss. Otherwise it weakens this overhanging portion of the gable end truss. So this geometry here with a shortened outlooker is very typical. At least that's what I see a lot of in my practice. And then notice we also put heel just to finish this out. And this is an option you can enable or not enable, but we enabled the heel or not heel, but sorry, the outlookers are at the peak, just to finish off that peak. So that in a nutshell is kind of what you have for basic truss geometry, creating trusses. So I'm going to just go ahead and just delete these real quick. And as you can see, pretty easy to create and delete them. They're all grouped nicely, so that makes it easy. I'm going to show you a monopitch truss now, and it's no different. You just go ahead and click anywhere you want. Start your point. Let's just do a 26-foot truss, and let's say 32 feet. Now you have these different options for monopitch, 3-3. This has to do, of course, with the webs, internal webs. And by the way, these numbers here talk about the number of panels between that are inside the truss. So I'm going to select the 3-3, and then I'll explain what those panels mean. Okay, we're just going to leave these options all the same for now. We'll go ahead and Gable End Truss it. Advanced options, yes. And I don't know if I've got structural outlookers oriented for this one yet, but let's go ahead and just leave the options as they are for now. Okay, so there's a monopitch roof. And so the first thing I'm going to show you really is, and notice we've got the gable end trusses again. These are non-structural outlookers in this case, we selected. And we have one at the peak, and whether you need that one or not is debatable. And if you don't need it and you create it, well, you can easily delete it. Just like that. So let's take a look at this truss real quick. So I'm going to grab it, or at least grab a copy of the component itself. Okay, so why is this called a 3-3 mono pitch? Well, if you look, there's what are called panels. So right from here to there, to there, to there. So there's 3 panels on the top, and there's 3 panels on the bottom. So that's why it's called a 3-3. And that's what those numbers signify. And basically, the larger the truss is, the more internal webbing you're going to require, because basically the length of this panel can only get to be so long before this member gets too long for its size, and therefore in bending and lateral buckling and that sort of thing, it's going to have issues. So that's why as you get a larger and larger truss, you end up having to use more webs. So for instance, now let's say we're going to do like a 50-foot truss. Well, typically you're going to see, if you take it to any truss manufacturer, they're going to want to use like a double think or something like that. So let's throw a double think at it and see what that looks like. Okay, so, and I'm going to actually, this time I'm going to not turn on the Gable End Truss, and I'm not going to turn on the advanced roof options. So you're just going to see what happens then. And notice there's no outlookers, there's no rake, there's no Gable End Trusses, and you can see the geometry of this double think. And you can see it's a rather large truss, and it has a lot of internal webbing. So basically, if the length between these panel points, as they're called, gets above about 10 to 12 feet in general, then once it gets beyond that, it gets too long and you have to use more webs. So anyways, yeah, I think that's probably pretty good for now. Next time we'll go into making floor trusses and floor joists and that sort of thing. To end off though, let's go ahead and just draw a basic attic truss. So and the attic truss options, there's quite a few options having to do with attic trusses. So we're just going to go ahead and put that guy right here. And I'm going to do a 28-foot span, and let's say a 32-foot length of the building. And with the attic truss, there's more options because the attic truss itself is more complicated, and and you can see right off the bat there's an attic width. And typically the attic width shouldn't be, it should be about half the span of the truss, but it can deviate slightly from that. And the attic height in this case is basically 8 feet tall, plus a little extra added for the sheeting on the floor. But as you can see, this height, you can configure that as you like. And I've actually created some logic within the plugin itself, so that if these heights and widths get too far out of what the norm is, then it will auto-correct those for you, or try to anyways. But typically that geometry you've already determined as a designer, or you already kind of have an idea what you want, and then you just put it in, and it'll complain if it doesn't particularly like it. The max truss height, and most of these other options, by the way, are very similar to the other options in normal common trusses, so I'm not going to re-go over those. But a couple of special options here is the max truss height. So this 11 feet, that basically will create what's called a piggyback truss out of your attic truss if the overall height of the truss exceeds this truss height. So in this instance, given that this truss is fairly large, it will create a piggyback truss, and 11 to 12 feet is usually pretty typical for max height of trusses that can ship down the road. That's what that is all about. So let's just go ahead and hit OK. Right now with attic trusses, there is no Gable End Truss option, so even if you click that, it should just ignore it. But let's just leave that off for now, and let's just go ahead and leave this off. I just want to show you the geometry to start with. So hit OK, and so here's our typical attic truss. So as you can see, it's gone ahead and it's created a piggyback on top of this the lower truss. And once again, if we click in, it's each, this is an entire component, and it's basically created this whole little component, and this piggyback is part of that main component. It's not a separate component, but but you can see the basic geometry created with an attic truss, and as you can see, it's a rather complicated geometry, and the logic actually behind creating that geometry is fairly extensive, so I won't get into all the details. But anyways, what ends up happening a lot of times too is, as you'll notice, this member, the top core member, is substantially thicker than this overhanging portion, and you specify this depth because you want to get insulation here through this diagonal region of the ceiling, and that depth you actually specify. But this is typically 2x4 here or 2x6, and you don't care that this overhanging portion is 2x8 or 2x10 in depth. So that's why this configuration is very typical for this type of truss, where you have a double split top chord, as I call it. So anyways, this is the beginning of what is capable with SketchUp with trusses, and there's yet a lot more that needs to be done, but this is the first tutorial for the Medeek Truss Plugin. And I appreciate you watching, and we will try to come out with some more videos here shortly. Thank you.